potential energy. The spring potential energy is given by half kx square. So this one we will use during the questions. Okay, so look at the first question. A block of mass m moving at a speed v compresses a spring through a distance x before its speed is halved. Find spring constant of the spring. So a block is moving. Suppose a block is moving, okay, and a spring is there. And after striking with the spring, it compresses it. The block of mass m moving with speed v compresses the spring through a distance x. Compresses the spring through a distance x before a block of mass m moving with speed v compresses the spring through a distance x before speed is halved. So initially the speed is v, okay, and after it is compressing the spring. Suppose it compressed the spring by some amount. Suppose it compressed the spring by distance x, and its speed becomes half. Okay, half the original value. So find the spring constant. So how to solve this question? So what are the different forces on the object acting while it is compressing the spring? So the forces are normal, the mg, and there is a spring force. Only three forces are acting. Okay, so spring force is conservative force here. Mg is also conservative, but Mg is not doing any work because the object is moving along horizontal, and the normal will not be able to any work. Okay, so energy of the system will remain conserved. So if we write delta U plus delta K equal to work done external, so only work done external here is the normal, and that is 0 because normal is perpendicular and displacement is normal is vertical, displacement is horizontal. That's why. Okay, so these two are perpendicular. So delta U plus delta K. So delta U we have to write here spring, for a spring, not for gravitation, because gravitational potential energy is not changing. Object is moving along horizontal direction, so no change in gravitational potential energy. So even if we write this, suppose even if we write gravitational, if we write like this, both the energy, if we write, this one has to be 0. Okay, and delta US, the spring potential energy. So how much it will be? Half kx square final potential energy, and initial was 0 because initially the spring was relaxed. Okay, and then change of kinetic energy. So final is half m v by 2 square, and initial is half m v square. So initial is half mv square because initial velocity is v, and final is velocity v by 2. So half m v by 2 square. So this we have to take as 0, and now we have to find. So half kx square, and this side it will be half mv square, and it will be 3 by 4. So half cancel, and x or k is equal to m v square by x square 3 by 4. Okay, so this will be the value of spring constant. So in this way we can find. So whatever is the loss of kinetic energy of object, the whole energy is going into the spring potential energy of the spring. Okay, is it